Yeah, thank you very much. Hello, everyone. Welcome to my talk on speed as a workplace habit influenced by test-driven development. So before we go ahead, I want to give you a little bit of background behind this talk. So I was introduced to TDD somewhere around 2012 in one of the uh, code retreats organized by Dr. Venkat Subramaniam. So it was a one-day event where we were pairing with different programmers with working on different languages and solving one problem throughout the day. The only constraint for us to solve this problem was to test drive the entire solution. That was the only constraint. But it was not until 2017 I started practicing TDD on my day-to-day work. Right, it came out as a surprise because I and Venkat, we were having a conversation, and then he was asking me if I'm still writing tests, and I surprisingly I was not, and he was a little bit surprised. So when I went back to work, I wanted to give it a try, and then I started trying out TDD, and that's when I realized how valuable it is to my day-to-day work, and all the misconceptions that I had about TDD. Like for instance, writing tests is going to take you a lot more time to ship your code. I understood that was completely untrue. So ever since 2017, TDD has become one of my primary workflows. So most of my code, like maybe 90-95% of my workflow, is based on TDD. And fast forward to today, I have been using TDD for quite some time now. And then as a side effect, I've also noticed the way how I approach problems, both technical and non-technical at work. So this talk is about going and looking at a few examples and a case studies and showing you how we can take a closer look at the feedback cycles that TDD gives us, and then apply it into problems that are sort of not necessarily related to typing code. So when we talk about TDD and feedback loops, right? So what does a feedback loop entail? So basically, when we talk about feedback loops, there are a couple of things to think about, right? So the first thing is the system tells you that something is not right, right? So these are the kind of feedback loops that are the most valuable because they help us catch mistakes early on and help us course correct really quickly, right? And there are also another kind of feedback loops when that's basically telling you your system is clean or like things are working as expected. These kind of feedback loops help, but then they are not as helpful as the feedback loops that tell us things are not working, right? And negative feedback loops are also quite helpful because they help you to experiment much faster and then figure out different solutions in a very short amount of time. So before we go ahead and look into other examples, the first thing that I want to do is like take a look at one of the TDD cycle and then examine a few feedback loops within the cycle before we go ahead and look at other examples, right? So before we go ahead, I just want to give a heads up. Let's just revisit the 3 rules of TDD. So the first rule says write production code only to make a failing unit test pass, right? And the second rule is basically write no more unit tests than it's sufficient to fail, and compilation errors are also treated as failures, right? And the third rule is basically write no more production code than necessary to pass a failing unit test. So these are all the 3 rules for TDD. That we have revisited these rules, let's go ahead and take a look at how a TDD cycle looks like. So the first thing that we take for granted most of the time is the IDE, because without the IDE, the kind of feedback loop that we get from test-driven development can be completely different. And obviously it differs from platform to platform, but IDE is one of the tools that sort of shortens this feedback loop that we have while practicing TDD. So the first thing is we have a test. It's just like a regular test. And what we're going to do is we're going to create a class that is going to help us help this test for us, right? So we're designing a system that is greeting visitors. So we create a class called greeter, and then we invoke the constructor. But then the IDE is telling you, hey, you know what? Like I'm going to mark this in red because the class does not exist, right? So the next thing that you're going to do is sort of like say, hey, like how do I fix this? And then the IDE is going to tell you, maybe these are all the things that you can do. Either you can import the class from a different place, or maybe you can create a new class or a new function, right? So these are all the options that the IDE gives you. Then we pick the one that is suitable to our use case, and then we go ahead and create the class, and then now it's all normal, right? So the red is now black. So fast forward, so we end up writing more and more of the unit test by bringing in missing methods and all of that. And then when we complete, this is how it looks like. So we now have an API that has a greet method and then also takes in a username, and we're saying, hey, you know what? Like when we call this function with this parameter, this is what we have to get. And the next thing that we do is we attempt to run this thing. The test fails. Then we go back to the production code, write the minimum amount of code necessary to make it pass, and then we run it again, and then the test passes, right? So that's just one TDD cycle, and here are some of the key moments in the cycle itself. So the first key moment is the missing class. So when you reach this point in time, we said, hey, you know what, like there is this class called greeter, and then the IDE tells you, you know what, like the class does not exist, and these are all the things that you can do. So the first thing that we have to take into account is the latency between the time it takes for you to perform an action and then for a consequence to happen. In this case, like the greeter class, missing class turning red, that's it. And the latency is almost immediate, right? A second thing that's happening is, how does the system grab your attention? Does it play an active role in getting your attention? Yes, it does. So it actively gets your attention. And the third thing it does is like, what are the kind of the response that the system gives you when something like this fails? So here in this case, it's more suggestive. So excellent feedback systems with excellent feedback can suggest you what you have to do to like get out of a failing scenario, right? And let's look at another key moment. In this case, it's a failing unit test. So you have this test, no production code, and then it fails. So what is happening here? So now, if you look at the first criteria, the latency between the action and the time the time taken for the consequence to appear is immediate, right? Which is pretty fast. And the system also plays an active role in getting your attention, which means it's going to show this pop-up, and then it's going to ask you, and it's going to tell you with all the red icons and message telling you something failed. So the system is playing an active role in getting your attention. And the response is informative. In this case, the system tells you something failed, but then it doesn't really tell you what you have to do to fix it, right? So in both these cases, we can take a feedback loop, and then if we break it down, you can see that we have 3 different cases, and each of these have different values. And the third thing is like the passing test itself. So again, now we have a passing test, and then if you look at the latency, it's immediate, attention is active, and then response is informative, right? But in this case, it's a passing test. It's helpful, but again, it's still a good feedback loop, right? So if you look at, if you take any feedback cycle and if you break it down, then you will always have 3 different criteria against which you can evaluate the feedback cycle itself. So the first one is the latency. So how long does it take for the action and the consequence to happen? And then it can be immediate, tolerable, or forever, right? So these are relative metrics, and it really depends on the kind of system that you're working with. And I'm using like relative measures here, but then if you're trying to tune one of these parameters, then you can use absolute values, and then like, you can use units like milliseconds or seconds or hours or days or whatever that is suitable to your use case. The lower the better, because as the feedback cycle increases, which means it's going to be harder for you to go back and fix any mistakes that you have in the system. And systems can play an active role in getting your attention. Sometimes they can be passive, and sometimes there is none, right? And then the response that you get from the system can be suggestive, which is like excellent, and sometimes it can be informative, and sometimes there is no response from the system at all. So if you identify a feedback loop that is very inefficient in one of the processes or like the systems that you build, you can sort of look at where these things are and then try to improve one parameter at a time, right? And if you get all greens, that's the best kind of system that you can build. And in some cases, it's not even possible to build a system that has all attributes in green, right? So it's okay to have 1 or 2 in orange and sometimes maybe a few in red, but that's completely relative. As we go through more examples, you'll understand how this plays out. So the first thing is, since we're talking about speed as a workplace habit, right? The first thing I want to talk about is like how do we go with our shortcuts. This is my preferred IDE of choice. I mostly work on the JVM, so I use this IDE. And what I am using here is a plugin called Key Promoter. Key Promoter is a plugin that helps you learn shortcuts, and let's go take a look at how it does it. So when you click on the build button, Key Promoter sort of shows you this dialog and tells you, hey, you know what, like something is, so this is something that you need to know, right? Let's take a closer look at this. So now, when you're looking at this information that's popped up on the screen, you can see it has two pieces of information. The first one is the shortcut, right? So if this is an action that you're constantly using in your workflow, then it's saying, hey, you know what, if you want to build your project, you probably have to use Command F9, right? So which is like suggestive because the system is telling you what you need to do to prevent this pop-up from showing up, right? And the second thing it does is it shows the name of the action, and it also shows the click count, right? So for example, how often are you doing this, right? Maybe if you have a higher number, then probably you should pay more attention to the shortcut itself and learn it sooner, right? And this is also more helpful because the pop-up, the position of the pop-up is placed very closely to the action that you are performing, right? So it's very hard for you to miss something like this. So let's like break this down, right? So this here, the latency is immediate. The attention is active because like it's on your face kind of pop up, and sometimes it can get like really annoying. But then again, it's sort of like the system grabs your attention like really actively. And then there is response, and sometimes here the response is both suggestive and informative, which is like quite nice. But then again, we have like all three in green, which is an excellent feedback mechanism. Let's go ahead and compare another kind of learning shortcuts. So this is using a different plugin, and then let's say how this plugin solves the same problem. So again, IntelliJ, and then and if you haven't noticed anything, you probably have to look at the bottom right corner of the screen. There is a notification that tells you what you have to do, right? Let's take a closer look at this. So when we look at this, you still have the same amount of like, it's the same kind of information that you received with the previous plugin, right? So one is the shortcut, which is suggestive, which is excellent. Like, and then the second thing is both the action event and the click count, which is again informative. So the information here is no different from the information that we saw in the earlier scenario. But then the area where this plugin falls short is the notification is sort of always on the bottom right corner of the screen, and then it's placed usually far away from the area where you're performing the action. So for example, if you're clicking an icon on the toolbar, it still places the notification on the bottom right of the screen. So the developer has to play an active role to go and look at the notification to learn the shortcut, right? And that sort of becomes very hard because you're like already focusing on something else, and this kind of sort of is less effective than the plugin that helps you learn shortcut in the first place, right? So here again, the action is immediate, the attention is passive. So the system is not really trying to get your attention actively, right? It's showing this message, but then it's for you to go and look at it and learn the shortcut on your own time. And the response is both suggestive and informative. So if you go back and compare the two different systems, the latency is immediate, the attention varies because one tries to get you actively learn the shortcuts, but the other one is more passive. And personally, and also like within the circle that I've noticed, people tend to learn shortcuts much more faster when they're using the first plugin, which plays an active role in getting their attention. And then the response is the same, right? But then when you notice, we have one parameter that varies, but then that can have a large impact on the efficiency of the system that you're building itself. And this is the only non-technical portion in this talk, writing a blog. And as you've already noticed that I'm a non-native English speaker, and then I've always had difficulty writing longer blog posts, right? Because writing emails is much more easier because the only focus while you're writing an email is to communicate things well, and they're usually short. But then when you're writing a long form blog, then at least I become very self-conscious about my grammar and like the flow of the content, and there's like too many things for me to focus. So it's not like it's not very natural for me. So I still have to put in a lot of effort to write blog posts that looks at least decent. So I've been personally experimenting with a few things. The first thing was I used to write blog posts and then I used to edit them on my own, and more often than not I used to spend days and sometimes even weeks writing the content and then like even editing and trying to like figure things out on my own, right? And it was like very taxing, and I was not very successful in writing like a lot of blog posts, and most of my blogs were just drafts because I was too embarrassed to publish them, or did not have and also like did not have the time to go and edit each of these blogs. And then I also considered hiring content editors, but then it wasn't feasible for me because I wrote blogs very infrequently, and then it's also more expensive to hire content writers. And if you hire someone who's really good, they already have a lot of work, and there's quite a bit of back and forth between them before we can settle on something. So that also did not work for me. The other thing that worked for me was to get feedback from friends. So I have a bunch of friends to whom I can share a draft with, and then they give me feedback. And mostly the feedback is around the content and the flow, but it's not really about the grammar and the kind of things that I want them to pay attention to. It's quite helpful feedback, but then it's not the kind of feedback that I want. The other thing is like go use a tool that can do this for you, right? So if you're not really good at grammar, then find something that is really good at grammar. And that's when I came across this tool. So this is a tool that sort of helps me write like well, and then it also helps me. It has also helped improve confidence in my writing itself. So one of the things that I noticed when using this tool is I had three major problems. One is writing really long sentences. The second problem was to write like a lot of text in passive voice, and the third thing was with punctuations. But at least now this tool has helped me write shorter sentences, helps me with punctuations, and then I'm also more proactive and then write my text in active voice. So those are the things that have sort of helped me to improve my writing. And nowadays I can finish a blog post in like 2 to 3 hours, which is pretty good. And then I send it out for a 2 to 3 day review with my friends and then just publish it. So it's a quite helpful tool that has reduced feedback and also helped me learn English better. So this is the tool showing me like there is a problem with the text, and then I can go ahead and fix it, right? So, and sometimes if you have very specific goals, you can choose the kind of the style of writing that you want, and then the tool will help you to achieve that. So let's break down this feedback loop, right? So here the feedback loop is it's almost immediate, right? Probably depends on the latency of the internet, but then it's still almost immediate. The attention is very active. It underlines text, it highlights things in red or green or blue, like really depending on the context. And then the response can either be suggestive or informative. So there are times where the tool recommends me the right kind of syntax that I need to use, but then sometimes it can go ahead and say, hey, you know what, like maybe this is a sentence you have to rewrite, but I can't really tell you how, right? So it really depends, but then the feedback is somewhere between excellent and very good. Now, working with graphical user interfaces. So this is an example that I'm going to show you on a project where we were building a Git GUI client. And as most of you know, when you're working with GUIs, it's very, very hard to unit test them, right? So UI is one of the things that more often than not requires human intervention. A portion of it can be automated, but most of the time it's very, very manual. So let's say, let's go through an example. So this is a case where most of our logic is driven by tests, but then there are things that you need to work on the UI. So the screen right now shows a very simple layout of the application itself. So I'm not showing you the actual screen, only one portion of it. So you have like two different panes, and probably you have a file menu. And when you click on the file menu, then there is an open repository screen. And then when you click on open repository, you are presented with a file picker, and then you can go choose a directory where you have a Git repository, and when you click on it, it opens the repository, right? And then from a list of commits that you have, you pick a commit, and the Git client is going to show you the kind of affected files, right? So this is the UI from the actual application itself, right? So now let's say we have problems with the scroll bars or like with the selection. And for us to fix this, this is a very painful flow to go through, right? Despite we have unit and integration tests that can prove the functionality of the UI component, but then problems with the UI component itself is hard to fix. And this is one of the cases where it becomes very inefficient, right? So let's go ahead and look at the feedback cycle that we have here. So the action is running the application, and like how long does it take for you to see the bug, right? That's the time it takes for you to see the consequence for your action. So it's sort of like forever because it's a very painful process, right? It's also not something that's very enjoyable for most of our developers to work with because you're clicking on too many different places to fix a bug, and can be sometimes very discouraging if the bug is still not fixed. So the attention is there is none. Like we don't really know if you have fixed it. We have to manually go look at the system and then understand if something is going on, if whatever we did has fixed the system or not. And then the response is none, right? Like the system does not really give us any feedback. So we still have like sort of a feedback cycle, but then a suboptimal one, right? So how do we do better? So one of the things that we try to do is build the application in such a way that each of these components can be mounted on their own. So here is where you're looking at a portion of a code base where we mount only the component that we have to test, right? So on the left side, you have the actual component. On the right side, you have a bunch of controls, right? So the top of these controls are the ones that are the inputs to the component itself, right? The architecture that we have requires you to specify boundaries in terms of values or streams of values. So the things that we need here are the repositories. So the list of repositories are fetched from a directory on the developer's machine, and then you have a file that you can pick, and then there is a list that contains all the list of commits. So that is your input, and then as you vary your input, the thing on your left changes. So and then there's this output, right? So if you're selecting an item on the list, then there's a callback that tells you what happened within the list, right? So this is a tool that can sort of like save you a lot of pain and then like lift the UI so that you can test UI related bugs or UI development slightly more faster. Let's evaluate this one, right? So still, earlier when we looked at the previous approach, it was forever and there was no attention, there's no response, right? But now it's tolerable because this cycle is like slightly more faster than the previous one, right? So when you're trying to fix a bug, you're still using the UI, but it's not like as painful as the earlier approach. So next thing, can we improve on this, right? Let's say, for example, hypothetically, we create a control. And since the values are all, the boundary between the component and the tool itself is values, we can sort of save the value, like, the path to the repository, the file, as well as the commit, and then we can automatically select the previous selection when the application starts up. So if we build a feature such as this one, then you can see that the latency between the action and the consequence can become immediate, right? So hypothetically speaking, so for example, if we want to improve on attention, right? So I may be completely wrong here, but then say, for example, we can sample a few frames from the beginning of the file and then save one of those frames to the disk. And then when the application starts up next, we sample again, get another image, and then compare the two. And if there are no changes, then we can, if there are changes, we can flash the UI, right? So if we can have a red border flashing around the component, that means that system is telling us, hey, you know what, whatever you did, there is some change, but then it's for you to go and look at it, right? So when you look at a feedback loop that's very inefficient, you can look into these individual parameters and then tweak them so that they can behave appropriately. The last one I want to talk about is an exploratory problem solving technique. Let's say, for example, you're building a privacy-focused personal finance application. So you're not like sort of letting other people read your email or having integration with a third-party application with your bank account, but rather using PDF statements that your bank emails you to keep track of your personal finances, right? To write such a system, you need to build something that can parse these documents and sort of derive these values and derive insights for you, right? So the problem with this approach is one, they're like different banks, so you may have to write like classes that cater to specific banks and specific formats. And then even if you have a PDF that you can successfully parse, if the bank changes the format of the statement, then it's going to be painfully difficult for you to figure out and add it to your new requirements, right? So the class of problem that we're dealing with here is where the requirements is not very clear and can change vastly among banks and even the same bank itself. So how do we deal with a problem like this? So one of the things that you can do is initially test drive a few reference statements and then sort of make sure that your code is able to parse these statements successfully. The next thing that you can do is expose this business logic, the parsing business logic, into a CLI application. And then you can build a CLI application that can take in a PDF and an input and then use a criteria to verify if the parsing was successful or not, right? So typically you can say, hey, you know what, I parsed all the transactions. Now, if I compute the debits and if I calculate the debits and credits, it should match the outstanding amount payable, right? So that's one way to make sure that your parsing logic is working as expected. So now when you have this kind of logic and then you have a CLI tool built in, you can pass this around to QA developers and QAs and other developers so that they can go run this on a set of data that they already have. And whenever there is a failure, you can pick up those sample data and these sample data become your new tests, right? So especially when you're working on a problem that is not well known or is not very what do you call it? The requirements are not clear, or you're in a position where you have constraints like the ones that I described above. You can go ahead and build CLI applications that can sort of like make it faster for your team and others to scale the discovery of your requirements and also discovery of bugs. So again, like these discovered requirements and bugs become your new tests in your system. So again, let's look at the action consequence time. It's almost immediate when you have a tool like this, because you don't really have to write a test or go through the UI to validate if you're parsing a certain PDF successfully. The attention is active and the response is informative. So this can tell you what failed, but then it can also be suggestive depending on how the criteria that you use to, the way how you build the tool, right? The tool can be smart, and if it's smart, then it's going to be suggestive as well. So we looked at a few examples at work and how you can sort of reduce the feedback cycles for the kind of work that you're doing. So excellent feedback cycles, they fail really fast. So if they fail fast, then that means you can course correct much faster. Then they also grab our attention. They play an active role and they grab our attention, and they can also be smart, and then they suggest corrective action. So these are the qualities of an excellent feedback cycle. And if you have a feedback cycle that's not excellent, the first thing that we have to do is to see, maybe can we make this excellent, or is it even worth to make it excellent, right? It's okay to have a few oranges or reds, because that really depends on the kind of system and the environment that you're working on. Closing notes, feedback cycles need not be excellent. It's a gray area, and then it doesn't have to be black or white. So you don't really have to aim for excellent. Having very good or good feedback cycles will do. And then you can apply this to smaller and larger systems. So for example, you can zoom in and then look at a single test or like a single verification of a PDF document, or you can take this and then apply it to your entire software development lifecycle, right? Take, for example, the moment you start from getting requirements till you deliver the product, right? Or even if you have a CI system, you can sort of look at it and then take a closer look at every stage and then identify the feedback cycles, break them down, and then see which area needs improvement. And again, like make sure that the kind of time that you're investing in improving the feedback cycle is rational. Don't go about improving the feedback cycle for everything. You don't have to improve everything to the maximum. Improving a little on various fronts can benefit you more than improving just one single thing. And command line interfaces are like excellent tools. They're like part of my standard tooling. So I use that most of the time to expose like a lot of, especially when dealing with problems that are more exploratory. So that's an excellent tool. Learn a CLI framework, it pays off very quickly. I'd like to end this talk with this quote: the only way to go fast is to go well, and fast feedback loops help us go really well. Thank you very much. And if there are queries, I can answer them for you.